Okay, we are going to talk about some conditional probability here. So we're going to work through these notes. Please make sure that you are taking notes on your packet and writing all this stuff down. Okay, so the first thing you need to know is how to understand conditional probability, kind of what it means, and then we're going to talk about how to calculate it so we can figure out the number for the probability. Conditional probability is the probability of an event occurring given that something else has already happened. So, for example, getting two heads in a row, that would be a conditional probability. So, you have to get the first heads and then you have to get the second heads. What's the probability of getting both heads? That's a little bit different than what we've done before. We've kind of touched on this a little bit in some of the homeworks. Independent events are events that are not affected by each other. So again, back to that tossing the coin. Each time you toss a coin, it's an isolated event. The probability doesn't change based on the previous toss. Each time it's a 50-50 shot. A dependent event would be events that are affected by a previous one. So drawing a card. When you draw a card, let's say you get an ace the first draw. Your second draw is affected by that because that ace doesn't go back into the deck. So the sample space has changed. We're now working with 51 cards instead of 52, and we only have 3 aces left in the deck, okay? So those would be dependent events, and then independent events are when each one is sort of a new probability. It doesn't change how many you're picking from or your sample space in any way. So let's say you have marbles here. You've got 30 of them. There's 10 red, 6 blue, 7 yellow, and 7 purple. We want to find the probability of choosing a red marble. Now it says without looking, that's meant to make you like it's random, okay? You're not looking to see, you're just reaching in, drawing out a marble. What's the probability that's red? That would be 10 out of 30 or 1/3. Now, if you put the red one back, we are not changing the sample space. So these are independent events. Choosing a red marble was a 10 out of 30 or a 1/3. And then choosing a yellow is a 7 out of 30. Okay, the first draw of the red does not affect the yellow. Those are independent events. Now, if we don't replace the marbles, then that changes each subsequent pull. So we have 30 marbles again. The probability of picking a blue marble, well, let me flip back real quick, was 6 out of 30 or 1/5. You would have a 1/5 probability of picking a blue. So let's say you do that. You pull out a marble, it's blue, great. The probability of picking a purple, well, we have 7 purple marbles still in there, but we no longer have the 30 marbles. We have 29. So it would be a 7 out of 29 chance of picking a purple. Okay, so that's the difference between independent and dependent. Most of the time it says with or without replacement. With replacement is independent and doesn't change the sample space. Without replacement means that you're not putting it back, and so the sample space changes. Okay, it's kind of common sense. But you got to think about it a little bit. So the goal of blackjack is to score 21, which you do by getting a face card, which is worth 10 or a 10, and an ace, which is worth 1 in this case, okay? Or 11. What is the probability of drawing an ace given you've already drawn a king? So you've already drawn that king. Now you're working with 51 cards, and you have 4 of them being aces, so the probability of drawing an ace after drawing a king would be a 4 out of 51 chance, okay? What's the probability of drawing a 6 given you've already drawn a 10 and a 3? Well, now you've drawn 2 cards, so your deck is only 50, and you have 4 sixes left, so you would have a 4 out of 50 chance, which that one you can reduce to 2 out of 25. So think about how the sample space changes as you're drawing these different things, okay? Here we have some information. Miss Wakehoff surveyed all the geometry students and made a list of the different sports that they play. What's the probability that a student plays track or soccer? So this goes back to kind of what we were talking about before. Track is a 68, soccer is a 106, so then we add those together and we take 106 plus 68, and that's, 174? Assuming my math is good here. We get 174 out of, now we have to figure out the total number of people that Mrs. Wakehoff surveyed. So we have to add in the people who play tennis, gymnastics, and swimming, okay, and get our total amount here. And this is where it might be helpful to have a calculator. Just to kind of do that math a little quicker and not have to do the mental math. So if we add up the 106, the 45, the 54, the 82, and the 68, and we get a total of 355. So the probability of a student playing track or soccer would be 174 out of 355. Okay? What's the probability that a student plays soccer given that they do an outdoor sport? So now we're only looking at the outdoor sports, so we can take off the gymnastics and the swimming, which is not an outdoor sport. Now I'm just going by what we would consider, here at our school, what's an outdoor sport. And so now we're talking soccer is 106, but that's going to be out of 106 plus 45 plus 68. So the sample space changes a little bit because we took out the indoor sports players, okay? Mr. Denoyer spent last weekend tracking all the Smarties that he ate because apparently he has nothing better to do with his time, and then graphed his data. What's the probability that the next Smartie that Mr. Denoyer eats will be a blue one? So this is empirical data, okay? This is not theoretical. This is empirical because it's based on observations, Mr. Denoyer's observations of his number of Smarties. Now let's talk real quick about what these half Smarties mean. You have to look at the key at the bottom, okay? And the key at the bottom tells you that we're talking about one circle, meaning 2 Smarties, okay? So make sure that you're paying attention to that. So each of these halves equals 1 then, all right? So what's the probability he'll eat a blue one? It's a 5 out of, but now we need to add up the total here and see how many we're talking about. So there's a total, I'm just going to write it in this bottom box here, of 55. So the probability that he gets a blue one next is a 5 out of 55 or a 1 out of 11, okay? If the package of Smarties that Mr. Denoyer is currently snacking on has no blue or brown, so now we're going to take out the blue, we're going to take out the brown from the total. What is the probability his next candy will be pink? Well, pink is 6, right? Out of, but now let's take the 55 and let's subtract the 5 and the 3, and that would be 47. So he would have a 6 out of 47 chance of getting a pink one for his next Smartie. If Mr. Denoyer hates green Smarties, like any normal person does, and throws them all away, what's the probability his yellow Smartie is next? So this time we're going to take the 7. Remember, our total was 55, so now we're talking about 48. And then yellow is 11. So it's a probability of 11 out of 48. So each time we're kind of tweaking the sample space a little bit to change how many are available for us to then pick from, okay? All right, here we have a graph of flavors of ice cream, and it's broken down by age or age category, I guess you would say, and then what flavor they like, okay? So what's the probability you would choose chocolate given you are under the age of 18? Well, under the age of 18 means we're taking out all of the adults from the totals, okay? So chocolate has a total of 52 out of, but then we need to add up these 6 numbers here. So 40 plus 22 plus 15 plus 12 plus 16 plus 45, and that means out of 136. Okay, and then of course we can reduce this, and we get, let's divide by 4, 13 over 34. Let's try another one. What's the probability you would choose vanilla given that you are a teen? So now we're only looking at the teenage numbers, okay? So vanilla is a 16 out of, and then we're just going to add up those 3 numbers, and we get 73. So are you kind of seeing how this works? We're tweaking the sample space based on the group or the qualifier that we're interested in. What's the probability that your teacher would choose neither? Well, I have to tell you, I am not a child or a teen. I am only an adult. So we're just looking at the adults section here. And the probability that I would choose neither is a 10 out of, and then if I add 55 plus 54 plus 10, I get 119. Okay? I hope we're starting to get this. I hope it's making sense. Go ahead and do your homework assignment. That is, again, linked on the calendar. And remember, we have a test coming up when we return from spring break.